Tahniah. Secara langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Secara langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai semua, Assalamualaikum, salam sejahtera dan selamat petang diucapkan kepada semua penonton, guru-guru dan pelajar-pelajar yang dikasihi walau di mana juga anda berada. Selamat datang ke Pusat Tuisyen Akademi YouTuber Malaysia dengan kerjasama e-didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Okay, pelajar-pelajar semua, hari ini kita bersama lagi dalam satu lagi kelas fizik tingkatan 5 yang akan disampaikan hari ini oleh Mr. P. Hi Mr. P, how do you do?
Hi, I'm fine.
Okey, bagus ya. Okey, jadi diharap anak-anak juga sudah bersedialah di luar sana. Okey, jadi sebelum kita mulakan kelas kita pada petang ini seperti biasa, jom kita mulakan dengan umul kita Al-Fatihah dan bacaan doa belajar. Bagi yang bukan Muslim bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya rabbal alamin. Sekali lagi anak-anak pelajar selamat datang. Kita tengok dulu siapa yang ada bersama kita pada petang ini. Kita ada Cikgu Kok di sana. Hai Cikgu Kok. Okey, kita juga ada Encik Aying di sana. Okey, dan cikgu percaya ada ramai lagi. Sebelum itu juga di sini kalau anda lihat Mr. P ada kongsikan link bahan yang akan kongsi pada petang ini saja. Anda bolehlah muat turun dan boleh juga cetak sekiranya ada printer di rumah. Okey. So hari ini petang ni kita bersiaran secara langsung dari channel Mr. P. Siapa yang belum subscribe lagi channel Mr. P, bolehlah klik butang subscribe sekarang dan juga klik pada loceng notification for all. So supaya anda akan menjadi antara yang pertama mendapat notification apabila Mr. P mengadakan kelas-kelas live di YouTube ataupun menguploadkan video-video PGPC yang terbaru. Okey, jadi anak-anak pelajar sebelum cikgu serahkan kepada Mr. P, Cikgu Hasnita pada petang ini bertindak selaku moderator dan juga sebagai pegawai teknikal, dan seperti biasa presenter kita semua sudah kenal Mr. P daripada dari Kolej Tingkatan 6 Tun Fatimah Melaka, dan petang ini kita akan belajar satu lagi topik tingkatan 5 masih lagi di bab 2 iaitu 2.5 Prinsip Archimedes, Archidemes Principle, dan kelas ini akan disampaikan dalam Dwibahasa lah. So yang dalam kelas DLP dan juga bukan kelas DLP boleh mengikuti siaran ini. Jadi jom kita share-sharekan lagi link kepada rakan-rakan yang lain. Mudah-mudahan lebih ramai lagi akan dapat manfaat daripada apa yang akan dikongsikan oleh Mr. P pada petang ini. Okeylah, seperti biasa kelas kita akan berjalan lebih kurang 1 jam dan di akhir nanti cikgu akan kongsikan link e-sijil dan juga link untuk anda isikan kod mata kredit. Menariknya kelas AYU ni sambil tengok kelas secara percuma anda juga bolehlah tebus hadiah dan ganjaran yang menarik. Apakah hadiah yang disediakan? Boleh lihat link dia pada deskripsi video ini. Okey, cikgu berikan dahulu 2 kod. Yang pertama anak-anak dengarkan kodnya iaitu A2. Okey, 2 kod yang pertama A2. Okey, baiklah cikgu serahkan kelas petang ini kepada Mr. P. Silakan Mr. P.
Okay, so terima kasih kepada Cikgu Hasnita. Okay, so bersama saya pada petang ini. Okay, so saya Mr. P, okay, presenter anda pada minggu ini. Okay, so saya dari mengajar di Kolej Tingkatan 6 Tun Fatimah Melaka. Okay, so hari ini merupakan hari ayah kan. Okay, so saya di sini mengambil kesempatan, okay, mengucapkan Happy Father's Day, okay, kepada ayah saya, okay. So semoga dia sentiasa sihat, panjang umur, okay. So sentiasa bahagialah, okay. So kedua saya pun terharu, okay. Saya sempatlah baca greeting card daripada anak saya lah. Okay, so semoga anak saya juga sihat, belajar bersungguh-sungguh. Okay, so saya rasa hari ini merupakan satu hari yang istimewa kan. So para pelajar, anda boleh ambillah kesempatan ini untuk tunjukkan kecintaan ayah anda. Okay, so sebenarnya sebagai seorang ayah, so kita sentiasa harap anak kita sihat, belajar bersungguh-sungguh. So jadi sosial dan akademik daripada anda merupakan satu hari yang terbaik kepada semua ayah anda kan. So sebagai cikgu akademik YouTuber, so cikgu boleh bantu anda mencapai akademik yang lebih cemerlang lah. So sila ikutilah kelas tuition percuma daripada AYU. So untuk kelas tingkatan 4, sekarang kita sudah sampai subtitle 2.8 berat. So baru-baru sahaja disampaikan oleh Cikgu Izian. So siapa yang belum tonton, so atau ikuti kelas tersebut, bolehlah pergi visit channel Cikgu Izian. Dan minggu ini sampai saya, so saya Mr. P akan sampaikan tajuk 25 Prinsip Archimedes kepada anda, iaitu merupakan satu tajuk sambungan daripada bab 2. So hari ini saya bersama cikgu, Cikgu Hasita, bersama anda di konti, untuk kelas hari ini. So ini merupakan panitia fizik SPM yang banyak memberi sumbangan kepada subjek fizik, di pendidikan Malaysia. So I will continue the subtopic for chapter 2. That is the Archimedes Principle. So in this subtopic, we have total 4 learning standard. So for the first learning standard 1, so it is regarding the relationship between buoyant force and the difference in the liquid pressure at different depth for a submerged object. So let us go through together what is the learning standard 1 you need to know. So here you can look at the figure, a ship made of the steel that weighs several hundred tons but still can float on the water. How does the situation occur? So you can look at the figure. So the arrow downward showing the acting force of the weight downward. So here this happened because of the buoyant force acting on the ship. So the buoyant force causes the ship to not sink into the water. So today we are going to discuss this phenomenon. So first, what is the means by the buoyant force? Apa maksud daya apungan? So the upthrust or buoyant force acting on an object is equal to the weight of fluid displaced when the object immersed completely or partially in the fluid. So that means that the upthrust force shown by red arrow here is actually also known as buoyant force. So the force will have the same weight to the water displaced. You can see there is the amount of the liquid in the beaker. So the weight of the fluid will be equal to the buoyant force. So this phenomenon is related to the Archimedes Principle. So what is the Archimedes Principle? So Archimedes Principle states that object which is fully or partially immersed. So here we have two figures. So the first figure, I write as A here. So you can see there is partially immersed. So the block is partially immersed. while for the figure B, okay, so the block is fully immersed. Okay, so the object fully or partially immersed in liquid will experience buoyant force. Okay, so the buoyant force will be upthrust force, as I mentioned just now. Okay, so the buoyant force, I set as FB here, will be equal to the weight of the fluid displaced. Okay, so from this figure, you can see the figure A, the volume of the block immersed will be less than B. Therefore, the water displaced for the B will be more than A. Okay, so this is the Archimedes principle. So the conclusion here means that the buoyant force, the FB I stated here, will be equal to the weight of the fluid displaced. Okay. Okay, so firstly, we relate the buoyant force with the actual weight and apparent weight. Okay, so here we have three terms, okay, you need to understand. The buoyant force I already mentioned just now. So here, the actual weight and the apparent weight. What is the difference between these two physics terms, okay? Okay, so buoyant force makes things seem to be lighter. So for example, here you can see the actual weight of the, here maybe is a bulb, okay? So in the air, showing the weight is about 25. When immersed into a fluid, here is will be liquid water. So you can see the reading is decreased. So showing that the buoyant force making the weight of the bulb here become lighter. Okay, so the weight of an object in the air is known as actual weight. So that means in this figure, okay, so the actual weight is 25. Okay, the symbol here I set as WC. And next, the weight measured when the object is immersed in a fluid is its appearance weight. So this is showing at the second figure here. Okay, so the appearance weight is equal to 10 if following the diagram here. Okay, so the appearance weight loss of the buoyant of the object is due to buoyant force. So here you can see there is about 15 loss of the weight. Okay, so we know as appearance weight loss, and the appearance weight loss will be the value for the buoyant force. Okay. Okay, so let us go to the more detailed explanation regarding the relationship between the buoyant force, actual weight, and the apparent weight here. So an object is adding by two forces. Okay, so there is the actual weight, which is adding upward. Downward here. And the buoyant force, which is adds upward. So with this. Okay, if let's say we draw at the diagram here, the weight will be here, and the upward force will be upward. Okay, so the buoyant force is equal to the apparent loss weight. Okay, so from here you can see how many, what's the value of the apparent loss weight. So 25 minus 10, you get 15 Newton. So that means that the loss of the weight will be equal to buoyant force. Okay, so we have the first relationship equation here. Okay, so buoyant force is equal to actual weight, which is 25 here, minus to apparent weight, which is 10. Okay, so here will be 15. Okay, so the FB here will be buoyant force, which is equal to 15. Okay, so next let us discuss about the relationship between the volume of the object immersed and the volume of the liquid displaced. Okay, so from here you can see when we slowly put down the block, okay, so for sure that the water will be rise and then flow out. So the volume of water or any other liquid you use, okay, the place here will be equal to the volume of object immersed. So here will be this part only. Okay. Okay, so from here you can see the volume object immersed. A is smaller than B, so the B is whole block immersed in the water. So that means the water displaced will be more. Okay, you can see the volume of water displaced in bigger A is less than B. Okay, so that means that the object is displaced the volume of water. So this one is actually quite related to the science PD3 you learn in Form 1. Okay, where you measure the volume of irregular shape of the stone example. Okay, so you use the displacement method. Okay, so the volume displaced equal to the volume of irregular shape of the object. Okay. Okay, so the bigger the volume of the object immersed, the bigger the volume of the liquid displaced. So that means here you can see here we have bigger volume. Okay, bigger volume. Sorry, here will be bigger volume for the figure B. So that means the water displaced will be more. Okay, so in this discussion, we can conclude that the volume of liquid displaced in the figure here, okay, will be equal to the submerged part of the object. Okay. Okay, then relate buoyant force to the weight of the liquid displaced. Okay, so what's the relationship between the buoyant force and the weight of the liquid displaced? Okay, if according to Archimedes principle, the buoyant force will be equal to the weight of the liquid displaced. Okay, so let us discuss the experiment together here. Pour water slowly into a urethral can, okay, until it flow out from the spout. Okay, so wet an empty beaker and place it under the spout of the urethral can. So here showing 0, normally we will take the value to 0 lah. Okay, so we no need to calculate again minus the empty beaker weight. Okay, if we follow the figure here lah. Okay, then suspend a weight at a hook of a spring balanced by a string and weight it in the air. So the value here, 4 Newton, is actually the actual weight, okay, for the weight, for this weight lah, okay. Okay, and then lower the weight into the urethral can. Okay, here we lower the weight, okay, into the urethral can, okay, until all the weight, okay, is completely immersed into the water. Okay, so the reading showing that that is a 3 Newton. So this is the weight. This is the weight of the liquid displaced actually. Okay. Okay, so record the reading of the spring balance, which is equal to 1. Okay, so when there is no more water flowing up from the spout, weight the beaker and water. So here actually the reading showing is the water displaced lah, okay, which is equal to 3. Okay, so according to the formula just now, the apparent loss 4 minus 1 is equal to 3 Newton, which is equal to buoyant force. So we can see that when we measure the displaced water here is also 3 Newton. So that means that the buoyant force is equal to the weight of liquid displaced. Okay, so here we have the clear calculation. So the first weight in A, so the weight is this lah. Okay, is equal to 4. So the actual weight is 4. Okay, we know as actual weight. And the second, we get our apparent weight, which is the weight of the weight in water. So we get 1. So according to our first formula, for buoyant force is equal to actual weight minus apparent weight. So we get our buoyant force is actually 3 Newton. Okay, and then from this experiment, we also prove that the weight of the displaced water is also 3, which is equal to the buoyant force. So we made our second conclusion here. Besides, for the first, we mentioned that the buoyant force is equal to actual weight minus apparent weight. And then here we come to another relationship to buoyant force, which showing that the buoyant force is actually the weight of the water displaced here. Okay. Okay, so next relationship we going to discuss is the buoyant force to the difference of liquid pressure at different depth level. Okay, so as we already learned at our previous subtopic, when the object is deeper into the liquid pressure will be increased. Okay, so here we use this concept to form a new equation. Okay, equation of buoyant force. Okay, so let us discuss together. Okay, so let's say the pressure acting on the top of the slaughter mass is P1. So here, so the level will be here. So that means that P1 will be at high H1 here. So we have our first pressure, which is stated as P1. And then the pressure acting on the bottom, so that means will be here, which will be H2. So the pressure will be P2. Okay, so as a result, the net upward pressure, so the pressure at this part will be P1. Sorry, P2 is bigger, so P2 minus P1 here. Okay, so because we want to know the pressure at this part only, which is at the H here. Okay. Okay, so if the object has an area A, so what is the upthrust force? Okay, so again, as I mentioned that the H value here is actually the net pressure. Okay, net pressure, we're using H2 minus H1. So we get our net pressure will be H lah. Okay, if you're using the unit of water, okay, using of the unit of water lah. Okay, so and the force, the relationship between the force with the pressure will be with this formula. Pressure equal to F over A. So that means the F will be equal to P times A. Okay, so we get our first formula like this. The buoyant force, FB, equal to P2 minus P1 times A. Okay, P will be the net upward pressure. And then second, we get the second formula with the liquid pressure, which we already learned at section 2.1, I think. Okay, so H rho G. Okay, so we substitute the P1 minus P2 with H rho G. And then A we just carry together lah. Okay, so and then the volume is equal to area times height. The height will be H here because we want to know the pressure as the object only. Okay, so we arrange, we get the area equal to volume over H lah. So we substitute and we cancel out the H. We get our final formula. Okay, equal to rho GV. Okay, so this is the third formula or relationship for buoyant force you can apply, okay, in your question later on. Okay, so the rho representing as the density of the liquid. Okay, density of the liquid, and then the G will be the gravitational acceleration, and V will be the volume of water displaced. Okay. Okay, so here we count the summary of equation for the buoyant force. We have three. The first, buoyant force is equal to the weight of fluid displaced. Okay, so you can look at the figure here. The buoyant force equal to 4 minus 1, right? Which is our third formula. Actual weight minus weight in water. We get 3. So the value of buoyant force, 3 Newton here, is equal to the weight of fluid displaced. Here the fluid we use water lah. So will be 3 also. Okay, and then the last will be the formula. Okay, rho Vg. Just now I show you how we get this formula already. So you can use this 3 summary of the equation for buoyant force and apply at your question, whether essay or calculation. Okay. Okay, later on we have a detailed discussion for the formula lah. Okay, so let us go through together our first question today. Okay, so this is the question at the SPM 2010. Okay, so diagram shows an airship floating at constant height. So that means the height is constant. So firstly, we need to know there are actually 2 forces acting on the airship, which is the weight and the buoyant force as our discussion just now. Okay, so the upthrust as tested on the airship is equal to what? Okay, so we have 4 options A, B, C, D. Okay, so students, you can show your answer, okay, at the chat room. Okay, then we can discuss together. Okay, so firstly, as I mentioned that we have 2 forces acting on the airship, which is the weight, showing by symbol W at downward, and the FP is the buoyant force, which is the upthrust mentioned at the question here. Okay. Okay, so the tips here is when an object floats in a fluid, so here will be the atmospheric condition, will be air lah, is upthrust is equal to weight of the object. The upthrust here is the buoyant force, which will be equal to the weight of the object. Okay, so weight of the object will be B lah. Okay, so the answer will be B. Okay, and then the next question. Okay, so a solid block is suspended in the air by a thin thread from a spring balance. The spring balance gives a reading of 65 Newton. So this is actually the actual weight. Okay, if you're not able to imagine, you can draw lah. Okay, so will be like this lah. So in the air, the block will be 65 Newton, as per mentioned in the question. When the block is completely submerged in water, the spring balance gives the reading of 30. So the 30 is actually the apparent weight. Okay, so determine the buoyant force assessed by the water on the block. So we're using the formula where the actual weight minus to apparent weight, which is the reading of the apparent lost weight. Okay. Okay, so the buoyant force we get, the value will be 35. Okay. Okay, so we go to our next question. B. What is the weight of water displaced by the block? Okay, so as per discussion just now, the weight of the water displaced will be equal to buoyant force, which is the principle of the Archimedes. Okay. Okay, so here the answer will be 35 because the weight of water displaced will be equal to buoyant force, which we get the answer already at A. Okay, and then the C determine the volume of water displaced by the block. Okay, so we're using the formula rho GV. So the FB buoyant force equal to 35. And then the rho we get from the question, which is equal to 1000. And then the G is standard, which is 9.81. And then we rearrange the formula, we get the answer, okay, which is the 0.0035 meter cube. Okay. Okay, so the block is completely submerged. It's showing with this figure. Okay, so volume of the block volume displaced is equal to 0.0035 also. Okay, huh? So that means the volume of the block will be equal to volume of water displaced. Okay, so we have already finished our learning standard 1. We go to our learning standard 2. Okay, so relate the balance of forces with the state of rotation of an object in a fluid. Okay, so as I mentioned just now, we have two forces adding on the object, which is the buoyant force and also the weight. Okay. Okay, so here we discuss the example of condition that involve resolution of forces with buoyant force. So here we have the summary, okay, summary of table with 4 different conditions. Okay, so first will be the object moving upward. Second, object sink. Object is partially immersed and object is completely immersed. Okay, so for the first, so the blue line here is the water level. So the object is under the water or liquid, okay? So and moving upward. Okay, you can look at the figure here. So when moving upward, so that means that the upward force, which is FB, is greater than W. Okay, so the FB is greater than W. So the FB will be buoyant force and the W will be weight of the object. Okay, so second, we discuss the volume of the object, relationship between the volume of the object and the volume of water displaced. So they will be equal. So that means that the object A, the volume in the liquid here will be displaced the same volume of water. Okay, so if let's say the block is 20 cm cube, so the water displaced you will get also 20 lah. Okay, then the relationship between the object density and liquid density. So here, since the object is moved outward, so that means the density of the object is smaller than liquid. Okay. Okay, and then the second, when the object is sink, so that means moving downward. Okay, so the object is moving downward. So the downward force, which is the weight, will be greater than buoyant force. So, or you can state as the buoyant force is smaller than the weight. Okay, again, you can see that the object is fully or completely immersed into the water. So the water level is here. So that means that the object volume and the water displaced will be also equal lah. Okay, then the density, when the object moving down, so that means the density of object will be greater than the liquid. Okay, and then the next will be the object is partially immersed. Okay, so the water level will be here. Okay, so is it the buoyant force is greater or smaller? So here actually we have a quite common mistake made by the students. Okay, so here actually since the object is actually stationary, so the buoyant force and the weight is actually equal. So this is a quite common mistake made by the students. Okay, so you need to highlight for this relationship with the condition where the object is partially immersed. Okay, so the volume of the object immersed is only partially. Okay, so that means that the object, the whole object will be bigger, right? So that means the object volume will be greater than water displaced. So the volume water displaced will be only the volume where is under the liquid lah. Okay, so that means the object size is bigger than the water displaced lah. Okay, and then the density here, since the object is floating, so that means that the density of the object is also less than the liquid. And then we go to our last, this should be no problem. The main problem here will be, or mistake, actually the mistake will be here. FB equal to W for the partially immersed object. Okay, so for the object is completely immersed, so we confirm that FB and W will be equal. And since the object is completely immersed, so that means the volume of water displaced will be also equal to the volume of the object. Okay, and then the density will also be equal. Okay, so this is the flotation condition for different condition. Okay. Okay, so so we go to our question number 3. Okay, so this is the question for SPM 2014. Okay, so let us go to the question together. Diagram shows a log floating on the surface of water. Okay, so that means that there will be case C, right? So this is the object C, will be like this. Okay. Okay, so which statement is correct? So here the buoyant force is equal to weight and others lah. Okay, so as I mentioned just now, the principle of flotation for the object which is float or immersed partially. Okay, so that means that the buoyant force is actually same as the weight also. Okay, so the answer will be A. Okay. Okay, so for the question 4, so a rubber ball is dropped into the water. The ball sinks and moves upward after reaching a certain depth. So which pair is correct to show the relationship between buoyant force and weight? So sink, as per mentioned just now, sink will be moving downward. So moving downward, that means the buoyant force will be smaller than the weight. Okay. So this is the same application of the principle of flotation. So that means the same one will be referring to buoyant force is smaller to the weight. Okay. Buoyant force smaller than weight will be A or D. And then the second, moving upward. So that means the flotation. So the flotation condition will be go up. So the buoyant force will be better than weight. Okay, so the answer will be A. Okay. Okay, so we go to our next learning, standard 3. Okay, so this will be have total about 5 application I'm going to discuss with you. Okay. Okay, so the first is regarding the ship. So from figure, you can see that there is actually 2 forces applied on the ship, which is the upward force, known as buoyant force, and the downward force will be the weight. Okay, so a ship is very heavy, but it is still able to stay afloat on the surface of sea. Okay, as per our first slide, we mentioned that the ship is able to float is due to the buoyant force. Okay, so now actually it's a detailed discussion to the first slide. So this is because the buoyant force is equal to the weight of the ship. Okay, if let's say the buoyant force is less than the weight of the ship will be going to sink already. Okay. Okay, so how we can maintain or how we can make our heavy ship to float. Okay, so we need to know the basic knowledge of the density lah. So that means that we need to make our ship density lower than the density of liquid. So if formula of density will be mass equal to volume, so we need to increase the value of V, which is the volume of the ship, so that the overall density of the ship will be decreased and less than the water. Okay, so how we can increase the volume of the ship? So here is the statement. So the interior of the ship is made up of hollow. Okay, so that the overall density of the ship is less than the density of seawater. So that means the hollow condition of the ship already increased the volume of the ship, okay, and made the density of the ship is less than the water. Okay, so hence the buoyant force adding on the ship will be large enough. Okay, large enough to support its weight. Okay, so for this one, we can also explain by using the formula, which the FB, buoyant force, is equal to rho GV. When the water displaces greater, that means the buoyant force will be also greater. Okay, so that means that you can discuss by using first formula of density, and then second, you can apply for new knowledge regarding the buoyant force in your discussion. Okay. Okay, the second also actually the part of the application of Archimedes principle on the ship lah. Okay, so here we're using the Frimsol line. Okay, so the purpose of the Frimsol symbol on a ship. Okay, so what is the Frimsol symbol? So it is which you can observe at the ship. Okay, so there is a symbol. Okay, TF will be equal to tropical fresh. So that means this will be the fresh water. Okay, so that means the density will be lesser compared to seawater. Okay, so because the seawater contains of salt or mineral, and the density of seawater will be higher, slightly higher than the freshwater. Okay, so the freshwater can also referring to pond or river. Okay. Okay, so besides that, okay, the Frimsol symbol here is also including the temperature or weather of the country. Okay, so winter or tropical. Okay, so what's the different density between the seawater and cold season? So as we know that density is equal to mass over volume. So that means that when the water become colder, okay, so that means the volume will be decreased, and the water during the cold season will be increased compared to our tropical area lah. Okay, so that means that we can make the conclusion: seawater, the density better than freshwater. Second, the density for the water at cold season is better than the hot area, or known as the tropical zone. Okay, so density of seawater varies with location due to the different temperature and salinity of the seawater. So the temperature referring to the season, whether cold season or tropical area. Okay, and then the salinity will be referring to the seawater and the freshwater. Okay, so for B, Frimsol line is marked on the hull of ship to show the depth which are safe for it to navigate. So it is a guide to ensure the ship is loaded with the safe limits. So that means that you need to observe, okay, the level of water at different conditions. If let's say you at the cold season, okay, example, Europe country or China, okay, so you have to make sure that your loading will be maximum at W lah, right? W. Okay. Okay, so now we go into the detailed discussion, okay, regarding the, you can see at the figure, huh? So here at the river or hot season country, okay, so the food will be immersed deeper, okay, into the water lah, okay. Okay, so when we discuss this, we can discuss by using the formula. This formula, rho GB. Okay, so firstly, okay, you can see that a ship will be submerged deeper, okay, in the fresh water. Okay, fresh water, because the density of fresh water is less than seawater. I already discussed just now. Okay, so due to the salinity condition is different. Okay, so for this reason, the ship must displace more water to obtain the sufficient buoyant force to support its weight. Okay, firstly, because the weight of the ship is the same, so that means that the buoyant force at any condition will also remain the same. So this is the first discussion you have to know. So to achieve the same buoyant force, when we go to the river or hot season, so the density of the liquid is decreased already. So that means that to get the same value of the buoyant force, we have to increase the V, which is the water displaced. Okay. Okay, so moreover, a ship can float higher in cold season as cold water has higher density. Just now I already mentioned to you. Okay, so the cold season water has higher density compared to hot season area. Okay, so Cikgu Hasita, maybe we can take a break first.
Okay, Mr. Pei. So students, we take a short break, then we will be right back after this.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Okay, pelajar-pelajar, kita kembali lagi ke kelas tuition online percuma Akademi YouTuber. Bermula percuma, selamanya percuma. Sebelum cikgu serahkan kembali kepada Mr. Pei, cikgu nak berikan dahulu kod yang ketiga dan keempat. Jadi anda dengarkan kodnya betul-betul. Nombornya adalah 82. Okay, sekali lagi kod yang ketiga dan keempat, nombornya adalah 82. Okay, jadi kalau anda belum lagi muat turun aplikasi Akademi YouTuber di Android anda boleh berbuat demikian sekarang. Pergi saja ke Google Play Store dan search saja Akademi YouTuber dan anda boleh muat turun seperti biasa. Ada lebih daripada 20,000 video PDPC menanti untuk membantu anda dalam memahami subjek-subjek dalam SPM ini. Bukan saja untuk SPM, kita juga ada subjek-subjek yang lain untuk daripada sekolah rendah sehinggalah ke pra-universiti. Jadi muat turun aplikasi Akademi YouTuber di Android anda sekarang. Okay, Mr. Pei, jom kita sambung semula.
Okay, so thank you. Okay, Cikgu Hasita. Okay, so let's continue to our third application of Archimedes Principle. Okay, so this is regarding the hot air balance. Okay, okay, so balance added by two main forces. Okay, also the same. We have two forces applied on the balance. Will be upward force, which is a buoyant force, and the downward force will be the weight of the object, weight of the balloon. Okay, here. Okay, so the density of the helium gas is smaller than the density of the surrounding air. So normally, okay, we apply, besides the hot air, we also using the helium, okay, to the balloons lah, okay, because the density is smaller than the air, okay. Okay, so the density of the air is lower than the density of cold water, sorry, cold air around the hot air balloon. So hence large volume of the surrounding air is displaced by the hot air in the envelope. Okay. Okay, so the balloons experiences a buoyant force. Okay, so again, so this one you also can discuss by using the formula. Formula buoyant force equal to rho GV. Okay, so when we using the lower density of air, so we need to increase the displaced volume of air so that we can achieve the same buoyant force. Okay, the buoyant force is always the same because the weight of the balloon will be unchanged here. Okay, so buoyant force equal to rho GV as I mentioned already. Okay, so if the buoyant force is greater than the total weight of the balloon, so it will be accelerate upward. So when we're talking about the buoyant force greater, so that means the FB greater than W, so the balloon will be moving upward lah. Okay, but at the certain condition, certain height, because of the condition of air become colder when the altitude is getting higher, so the temperature of air become decreased. So when the density of the air be already reduced, okay, so the buoyant force will become slightly reduced lah. So the FV and the weight will be the same already. Okay. Okay, then the next will be the submarine. Okay, so the submarine has a ballast tank used to control the position and depth from the surface of the sea. So the ballast tank will be here, right? Will be here. Okay, so float on the sea surface, that means the ballast tank will be empty. So again, we discuss the density. When the mass of the submarine decrease, so the density of the submarine will be decreased also lah, huh? Okay, so will be floating on the water. Okay, when we fill partially the ballast tank, so the mass will be increased. Okay, so that the weight overall the weight of the submarine will be increased and greater than the buoyant force. So will be submerged or slowly move down lah. Okay, then the ballast tank is fully filled with water, so will be sink into the sea. Okay, so you can look at the GIF also like this lah. Okay, so that means that we can classify them to three conditions where the submarine float on the seawater. So that means that the buoyant force is equal to the weight. Okay, but density will be lower than the density of sea. Okay, can you see the difference? So the density lower than the seawater make it move downward, but actually move upward, sorry. But actually for the buoyant force is also maintain the same, okay, by applying the concept of principle of flotation. Okay, so when floats in the sea, okay, float in the sea, so the ballast tank is partially filled. So it is lah. So buoyant force is equal to the weight of the submarine. Okay, so this is considered as a completely immersed condition now. Okay, and then the density of the submarine is equal to density of the seawater. Then the last will be sink. Okay, so for sink, that means moving down lah. So the buoyant force will be greater than the buoyant force is less than the weight lah, so going down. Okay, and the density of the submarine is higher. So these three conditions, you can apply the principle of flotation. Okay, we discussed just now at learning standard 2. Okay, so the last will be the hydrometer. Okay, so you can look at the figure. This is a hydrometer. So what is the application for the hydrometer? You can see a hydrometer is an instrument used to measure the relative density of liquid such as the milk or acid in accumulator. Okay, so if I say put into the acid, so that means the material used by the hydrometer must be able to withstand the corrosive condition. Okay, okay, so it has a glass butt. Okay, so here mentioned already glass. So the glass is the material which will be able to withstand the corrosive, okay, corrosive from the alkaline or acid. Okay, okay, so it has a glass butt which contains some lead should. So be here, which should be here. Okay, make it float upright. Okay, so it has a long, narrow tube with a skew on it, which make the hydrometer more sensitive. Okay, so that means we prefer longer tube. Okay, so that we can measure wider range of the density and also make it become more sensitive. Okay, so the D, the large air-filled glass butt. Okay, here, that means the volume we also prefer bigger volume, okay? So that it can displace, okay? It can displace, used to, here is displace actually, used to displace more liquid and it causes the buoyant force to increase. Okay, hence the hydrometer floats. Okay. Okay, so in a liquid of lower density, the hydrometer is more submerged. Okay, so it'll be submerged more lah, because the liquid density is lower, so will be the overall buoyant force will be reduced lah. Okay, so we go to our last learning standard 4, problem solving involving Archimedes Principle buoyant force. Actually, this one is a discussion of the knowledge from standard 1, learning standard 1 to learning standard 3 lah. Oh. Okay, okay, so the first question, okay, so diagram 3 show a ball floating at the surface of water. So you can see this is actually the partially immersed condition. Okay, so name the upward force that is adding on the ball. So upward force will be buoyant force. Okay, if I say downward force will be weight lah. Okay, so here ask you to give the upward force. Okay, so number 2, give a relationship between force named in A1 and the weight of the object. Okay, so here will be the discuss about the principle of rotation. So that means this is a case of the partially immersed condition. So for the density wise, the density of the ball is less than the density of water. But as I mentioned, we have a common message here. Okay, always made by the students. So the flotation, the buoyant force will be equal to the weight. Okay, so this is the tips I already give you just now. Okay, so here will be the equal. Okay, because the object is floats or remains stationary in liquid. Okay, so the answer here will be equal. Okay, then the B, the mass of the ball is 0.2 kg and the density of the water is 1000 here, 1000 kg per meter cube. Calculate the volume of water displaced by the ball. Okay, so here the water displaced will be equal to the weight of the ball, which is the formula mg lah. You learn at Form 4, sections 2.8, okay? So mg will be equal to rho gv. So we substitute the value and here will be 0.2, so will be 0.2. We cancel out the g already. Okay, so I think will be 0.2 divide 1000 lah. 1, 2, 3. Okay, so the answer is correct. Okay, so here is 0.2. Okay, because we're using kg lah. Okay, so answer is correct. Just here you need to change to 0.2. Okay, so if only half volume of ball is immersed in the water, what is the volume of the ball? So just now we already look at the figure given by the question. So that is actually partially immersed only. Okay, so that means the volume we get just now is only equal to the half of the ball only lah. Okay, so just now we get the water displaced is 0.002. So this is actually the same volume of the half for the ball. So for whole, we need to times 2. So we get 0.004 meter cube. Okay, again, reminding you that our answer must together with correct unit. Okay, so what is the density of the ball? Okay, so density formula m divided by v. Okay, so m 0.2 given by question, which is just now it's 0.2 0.2 kg given by question. Okay, and then the volume of the ball is 0.004. So we get 500 kg per meter cube. Okay, so compare the volume of the cooking oil displaced with the volume of water displaced. Okay, so what is the main difference between the water and the cooking oil? So the density for the cooking oil is less than the water. Okay, so that means the buoyant force for the ball is actually remain the same because the weight of the ball is unchanged. So by using the formula, as per mentioned just now, we can explain by using formula. So the weight of the object remain the same. That means that the buoyant force is remain the same. But now the density of the liquid, okay, we use here reduce to get the same value of the buoyant force. We need to have the better displaced volume of cooking oil. So that means the ball will be immersed more, right? Okay, we using the formula to discuss. Okay, so as I mentioned, to remain the same buoyant force when the density of liquid decrease, the displacement of the fluid must be increased. Okay, so the cooking oil displacement volume will be increased. Okay, so we go to our last question. Okay, so this is a question regarding section C, will be a 20 marks question. Okay, so diagram 6.1 and 6.2 show two identical ships. So that means the weight for 6.1 and 6.2 will be the same. That means that the buoyant force will be also the same. Okay, so the main difference here is the ship is on the different type of water. So here we have the sea water and we have the river water. So as per our discussion at section learning standard 3, so the density for sea water is greater than the river water. Okay, so again, using your formula rho GV to remain the same buoyant force because they are the identical ship. So when the density decrease at the river water, so the displaced liquid volume must be increased. So you can see very clear that the ship at diagram 6.2, the H2 is lower, means that the ship is immersed deeper into the water compared to the ship in the diagram 6.2. Okay. Okay, so firstly state the Archimedes principle. So again, we discuss regarding the buoyant force and the water or fluid displaced. So will be the same, no matter that is a partially or completely immersed. So here you can see, here is a case of the partially immersed. Here we have the completely immersed cases here. Okay, so both fully or partially immersed in fluid will experience a buoyant force equal to weight of fluid displaced. Okay. Okay, then for the B, for section C is normally the conception question, and normally total we have 5 marks, and you have to do the comparison between two diagrams given. Okay, so here the question asking you to compare the weight of the water displaced, the density of water, and the volume of water displaced. Okay. Okay, so for the weight of the water displaced, you can see both is identical ship. So that means the weight of the ship is the same, and the buoyant force will be also the same. So the buoyant force is equal to the weight of the water displaced according to Archimedes principle. So it will be equal lah. Okay, so this is the first tip. Weight of the ship equal to the weight of the water displaced. Okay, so the answer 6.1 will be equal to 6.2, but you have to write your parameter here, weight of water displaced. Okay, and then the second asking you regarding the density of water. So density of seawater or diagram 6.1 will be greater than 6.2. Okay, and then the third asking you regarding the volume of water displaced. Okay, so for the volume of water displaced, we have to apply the formula. Okay, so as per mentioned just now, when the buoyant force the same as the density of the seawater is greater, so the volume displaced will be less. Or you can just observe the figure, H2 and H1. So the H1 is bigger, means that the water displaced by ship in 6.1 will be less. Okay, less than 6.2. Again, you need to mention your parameter. Okay, so this is a 3 mark, 3 point is given here. And then the second step, the relationship between the density of water and volume of the water displaced. So from here, you can see when the density increase, the water or the volume displaced will be decreased. So that means it's the inversely proportional condition. Okay, you can mention when the density of water decreases, the volume of displaced water decreases. Or you can mention that the density of the water is inversely proportional to the volume of water displaced. Also can. Okay, the last for conception question here, set the relationship between the weight of the water displaced and the buoyant force. So this is actually the principle of the Archimedes . So the water displaced is equal to the buoyant force . Okay. Okay, then next will be the 4 marks question for the theory discussion. Okay, so explain why the hot air balloon will move up and stop. So the main keyword first, move up. Why? Because we have actually 2 force adding on the balloon. The buoyant force is greater than the weight of the balloon. And then stop because, as I mentioned just now, when we go to the certain altitude, so the density of the air will be decreased. Okay, and cause the buoyant force decrease. Not the buoyant force decrease, actually, is the density overall outside is actually becomes smaller already. Okay, so we discussed with using the formula, the density of air decrease. Okay, so here decrease already lah. Then the weight equal to buoyant force at certain height. So that means that is the net force here will be 0 lah. So first, the altitude higher, density of air decrease. Buoyant force becomes smaller, and a certain height, the weight of the displaced air is same as the weight of the balloon. And then the hot air balance in equilibrium force, or you can say the resultant force will be 0 lah. Okay, FP and W will be 0 lah. Okay, so we go to the last 10 mark question. Okay, so diagram 6.4 shows the hydrometer used to measure the density of liquid. You are required to modify the hydrometer so that it can be used to measure the density of concentrated acid efficiently in your science school lab. So you have to explain and emphasize on the first material used by the hydrometer. So this one, just now we already mentioned we need to use the glass because it can withstand the corrosive, okay? And then the size of the bulb must be bigger, okay? And then the length of the stem here, okay, must be longer, okay, so that we can measure for wider range of density of the liquid, and the diameter of the hydrometer stand should be also bigger lah, so that can become more sensitive, okay? And diameter should be smaller, I think. Okay, later we see the answer together. And then the material for the base lid lah, that means the lid we are using, okay, to support or make the hydrometer stand lah, okay? Okay, so first will be, we need to do in table form. Okay, so we list out all the aspect asking by the question. The first will be using glass, okay, not easily rust, okay. Size of the bulb here will be big, okay, produce large buoyant force, okay, and then the length must be longer, long, so can measure wide range of density. Okay, diameter here is big lah, so more sensitive. Okay, here it become more sensitive, okay, and the material at the base we using lead, okay, so will be more stable. Okay, so I think the time is already okay. Not much, okay, so my discussion will be until here. Okay, thank you.
Okay, thank you Mr. Pei. Terima kasih. Okay, terima kasih juga kepada pelajar-pelajar yang setia mengikuti kita daripada awal hinggalah ke saat ini. Perbincangan tadi telah disampaikan oleh Mr. Pei ataupun nama sebenarnya Cikgu Pei Kok Hua dari Kolej Tingkatan 6 Tun Fatimah, Melaka. Jadi anda jangan lupa dapatkan bahan yang dikongsikan oleh Mr. Pei pada link yang ada pada deskripsi video ini dan juga telah kongsikan pada live chat tadi. Okey, jadi cikgu sebelum cikgu kongsikan dua kod yang terakhir, okey, suka cikgu minta siapa yang belum lagi subscribe kepada channel Mr. Pei, jom kita berikan sokongan kepada beliau. Anda boleh tekan pada butang subscribe di bawah dan jangan lupa tekan pada loceng notifikasi. Okey, terima kasih kepada yang setia mengikuti kelas kita setiap minggu. Kita akan bersiaran 2 kali seminggu untuk subjek fizik ini, iaitu pada hari Jumaat 9.30 malam untuk kelas tingkatan 4 dan setiap hari Ahad pada pukul 2 petang untuk kelas tingkatan 5. Okey, jadi cikgu kongsikan dulu link sijil untuk pelajar-pelajar Mr. P. Sebelum tu mungkin Mr. P ada sedikit pesanan yang terakhir nak dikongsikan kepada anak-anak pelajar kita.
Okay, so terima kasih kepada pelajar-pelajar yang mengikuti kelas saya lah. Hari ini saya nampak ada yang pelajar yang saya tak pernah tengok.
So
Afrina. So terima kasih lah anda mengikuti kelas cikgu. Cikgu P harap boleh terus sokong cikgu P, terus sokong cikgu Hasita, terus sokong kelas tuition AYU. So kamu mesti dapat sesuatu yang manfaat daripada grup AYU kita ini. So thank you.
Okey, terima kasih. So telah cikgu kongsikan link sijil kelas kita pada hari ini. Link ini boleh anda isikan menggunakan email EDD ataupun email MOE, email Jawi ataupun email My Guru. Dan ini adalah link untuk anda rekodkan kod mata kredit. Cikgu akan berikan sebentar lagi 2 kod yang terakhir. Dan jangan lupa masukkan username presenter kita. Ini ejaan yang sebenarnya, username presenter dia t.me/PKH. Okey, terima kasih juga Afrina. Anda boleh tonton semula video ini pada link yang sama. Boleh ulang-ulang tonton sehingga anda betul-betul faham apa yang telah dikongsikan oleh Mr. P sebentar tadi. Okey, jadi cikgu kongsikan 2 kod yang terakhir iaitu nombornya 46. Okey, 2 kod yang terakhir 46. Okey, anda masukkan kod-kod yang cikgu berikan tadi bila anda isikan link rekod mata kredit pelajar. Okey, jadi sekian saja daripada kami pada petang ini. Segala yang baik itu daripada Allah SWT, segala yang buruk itu daripada kelemahan kami. Semoga apa yang kami kongsikan pada petang ini memberi manfaat kepada semua yang menonton, khususnya pelajar-pelajar yang mengambil fizik di luar sana. Jadi jaga diri, rajin belajar dan jumpa lagi pada siri-siri yang akan datang. Okay, terima kasih kerana menyokong Akademi YouTuber dan sehingga kita berjumpa lagi.
Dibawakan kepada anda oleh Akademi YouTuber.